Hello dear students, we have completed module 5. From today session onwards, we will see topics from module 6. So discussion for today's session, it is RTOS, real-time operating system, service goals, structure, kernel, processor modes, services of kernel. Now we'll start with real-time operating system. So real-time operating system is shortly called as RTOS. Real-time operating system is shortly called as RTOS. So a real-time operating system is an operating system intended to serve real-time applications. A real-time operating system is an operating system intended to serve real-time applications that process data as it comes in without much delay. Or in other words, it is an operating system for multitasking designed for the real-time applications with hard or soft real-time constraints. The applications includes complex multimedia animation systems, industrial robots, embedded systems, scientific and research equipments, communication, and other systems that need real-time results. So let me once again say, a real-time operating system is an operating system intended to serve real-time applications. Now we will see operating system service goals. There are many important service goals of an operating system. Some of them are efficiently sharing of resources as per schedule and allocation. Efficiently sharing of resources as per schedule and allocation. So what exactly mean by resource? Resource can be a processor or processors, memory, input or output devices, pipes, sockets, keyboard, displays, etc. So a resource is a device which process requests from the operating system. So it is very important, if the resources are not allocated by the operating system, the processing task or thread cannot use it. Next point, facilitates scheduling, context switching and interrupt service mechanism. Facilitates scheduling, context switching and interrupt service mechanism. We'll see what is scheduling, context switching and all. So scheduling is nothing but the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. That strategy can be first come first server, round robin scheduling, short job first, many things like that, etc. Now the next terminology, context switching. Context switching means storing the context or state of a process so that it can be reloaded when required and execution can be resumed or restart from the same point as earlier. It is similar to push and pop instructions in the microprocessor. Next point, it facilitates easy implementation of the application software with the given system hardware. An application uses the functions provided in the operating system. Next point, facilitates the management of the processes, tasks, threads, memory, inter-process communication mechanisms, input-output devices and other functions. facilitates the management. So what do you mean by management? So the management means creation, resource allocation, resource freeing, scheduling, synchronizing, detection. So these are the management things. Next point, providing management functions for the input output devices, files and file like devices. Next one, providing portability of the application on different hardware configurations. Providing portability of the applications on different hardware configuration. Similarly, providing interoperability of the application on different networks. Ninth point, providing a common set of interfaces that integrates various devices and applications through standard system. Last point, the maximizing the system performance to make the different process, task, threads share the resources most efficiently. So these are some of the important service goals of an operating system. Next topic for discussion is structure. So a system can be assumed to have a structure. A system can be assumed to have a structure. That is, the structure can be top to down or top down. The other one it is bottom up. Here for consideration we are taking top down structure layers. That is, the top layer it is application software and the bottom layer it is hardware. So there are seven layers in top down structure. So first of all it is application software, second one application programming interface, third one system software other than the one provided at the operating system, fourth point operating system interface, fifth layer operating system, sixth one hardware and OS interface, finally seventh layer or seventh point, that is hardware. Let me say once again, it is application software, API, system software other than the one provided at the operating system, OS interface, operating system and hardware and OS interface, and finally hardware. Now we will see the functions of each layers in detail. The first layer it is application software. So this application software executes as per the applications run on the given hardware using the interfaces and the system software. Let me say once again, this application software executes as per the applications run on the given hardware using the interfaces and the system software. Now next one, API. API is application programming interface. It provides the interface between the application software and the system software. So API provides the interface between the application software and the system software so that it is able to run on the processor using the given system software. So the two things are over. Now next one is the system software other than the one provided at the operating system. The third point it is system software other than the one provided at the operating system. So this layer provides the system software services other than the OS services function. Let me say once again, this layer provides system software services other than the OS service functions. The next layer it is operating system interface. So it is nothing but an interface between the API, application programming interface, and the operating system. And the fifth layer it is operating system. And the sixth layer, it is hardware and operating system interface. So this interface is used to execute the functions on the given hardware. Let me say once again, this interface is used to execute the functions on the given hardware. Last one, it is hardware. So examples for hardware can be many things, that is processor, memory, interfacing circuits, IO input output devices, timers, ports, etc. So that's all regarding the structure, specifically top-down structure. Next we will see kernel. So kernel is a software program. Kernel is a software program and used to access the hardware components. So let me see once again, kernel is a software program and it is used to access the hardware components. Take the example of our mobile phones. Kernel is used to access the hardware components like camera, speakers, display, processor, etc. For example, you wanted to take a photo from your smartphone. What do? We click on the camera application. Immediately, camera hardware gets activated and you can see the objects in front of the camera. Now let us see how internally this works. Camera applications require a software to access the camera hardware behind the smartphone. Once it gets the permission, the camera starts. This software, that is this middle layer software, is nothing but the kernel. Again, you want to save the photos in your internal storage or in the memory card mounted on the phone. You again need permission of the kernel. Once you get the permission, you can save it in your storage or in the memory card or wherever you want. So kernel is basically a software that is a bridge between application and hardware. So the application or the software requires hardware through kernel. Now this is not only limited to internal hardware but also to external hardware like the printers or scanners. For example, we can browse on the internet. We found that one file needed to download and to be saved. To save that file, we need the kernel permission. And after getting the permission, it can be saved on your hard disk. Later on, when you open it again, if you feel like taking a printout, now the PDF reader will request the kernel for the external printer to print that PDF file. Let me say once again, the PDF reader will request the kernel for the external printer to print that PDF file. After getting the permission, we can print that file. So the permission is granted from the kernel. So basically, when application or a process starts running, they are in the user mode. Like in the previous example, while you were browsing the internet or reading the PDF, you were in user mode. But once the application or its process requests for hardware by any means or through kernel, you enter into the kernel mode or the supervisor mode. The requesting to the kernel is done through instructions or commands given to the kernel. So our program frequently switches between the user mode and the kernel mode. Any applications start running, it's in the user mode, then frequently switches to kernel mode for executing privileged instructions or accessing a privileged hardware. Now we will see in detail about the processor modes. Already we have seen the different processor modes, that is user mode and the supervisory mode, or generally called as kernel mode. Now we'll see the comparison of the supervisory mode as well as the user mode. So there are mainly 4 parameters to be compared. One is mode, second one is an interrupt, memory access and restriction. Now we'll see the comparison of user mode as well as kernel mode. So user mode is referred as, first of all we'll compare with respect to mode. User mode is referred as a slave mode or a restricted mode. So restricted means, which simply means application running in this mode has many restrictions on it. Whereas in kernel mode, or generally called as a master mode or a privileged mode, or we can call it as a supervisory mode. Here the applications have no restrictions at all. Second parameter, interrupt. If application running in user mode and if some interrupts occurs, only one process will crash or very little damage will occur. Whereas if you are running in kernel mode and some interrupt occurs or some problem occurs, the complete operating system damage. So you need to reinstall the operating system if it is in the kernel mode. Third parameter is memory access. In user mode, limited memory access. Private address space is allocated to it. But in kernel mode, you can access any memory location. There is no restrictions. The fourth point, restriction. If you are executing in user mode and you wanted to access kernel data structure or kernel programs, you cannot access them directly. But if you are in kernel mode or supervisory mode, you can access the common or user data structure as well as the kernel data structure and programs. So in short, the difference of user and supervisory, most commonly used mode is user mode. Both these modes are introduced to provide more security for the operating system. In kernel mode, you have unrestrictions to all the resources of the operating system. Whereas in user mode, we have limited access to the resource. And moreover, critical jobs in the operating systems are operated in supervisory mode. Also, the processor in the system frequently switches between the user mode and the kernel. So I hope you understood the comparison of user mode and the kernel mode or supervisory mode. Now we'll see the services of kernel. Mainly it has got 6 main services, that is process management, memory management, file system management, I/O subsystem management, device management and device drivers. Let me say once again, the services of the kernel includes process management, file system management, memory management, I/O subsystem management, device management and device drivers. So now in the next section or in the next class we'll be seeing all these things in detail. So I hope you understood a just brief introduction to real-time operating system. Thank you.